A crane's maximum capacity is only the beginning. One machine on this list moves its own counterweight while it lifts. Another uses two complete booms. One raised a 2,050-ton tower more than 360 feet tall. And at the far end, a fully assembled crane moves across a nuclear construction site on dedicated rails. We start with a problem every giant crane eventually creates. There is not enough room. The Manitowoc 31000 is rated for 2,300 metric tons, but its smartest feature sits behind the crane. It is called VPC, or Variable Position Counterweight. Every crane needs ballast to resist the load pulling against the boom. On some ultra-heavy machines, that counterweight rides on a separate wagon moving across the ground behind the crane. The 31000 keeps its counterweight suspended from the machine itself. As the lifting condition changes, the ballast can move from roughly 8 meters to almost 29 meters behind the crane, increasing leverage without forcing a huge counterweight trolley to occupy another part of the job site. That became especially useful during a lift in Gwangyang, South Korea, in 2013. A 650-ton cold box had to be installed in a restricted area beside a wall. The vessel stood about 55 meters tall, leaving little room for a giant crane and its support equipment. Another crawler helped raise the cold box from horizontal. Once it was upright, the Manitowoc took the full load, carried it, and placed it into position. The operation took less than 2 hours. The VPC did not make 650 tons lighter. It allowed a 2,300-ton class crane to control that load without demanding an equally enormous counterweight footprint behind it. The Demag CC 8800-1 solves a different problem. As a crane boom becomes longer, the boom itself becomes harder to control. The standard CC 8800-1 is rated for around 1,600 metric tons, but Demag developed a boom booster system for jobs where the crane needs extreme height without allowing the lower boom structure to become the weak point. The wider reinforced section increases stiffness, giving the crane more usable capacity on long boom wind energy work. Instead of replacing the entire crane, operators can change the structure carrying the load. But the CC 8800-1 platform had an even more extreme option. Demag could turn one boom into two. The result is the CC 8800-1 Twin. Two enormous lattice booms rise side by side and work as one lifting structure, pushing maximum capacity to roughly 3,200 metric tons. The reason is structural. A single lattice boom has to resist compression and bending while supporting both its own weight and the suspended load. There is a practical limit to how much larger one structure can become. The Twin spreads those forces across two complete boom systems. And despite the scale, the crane can still travel with a suspended load under suitable conditions. That gives operators another option during complex lifts. The crane can raise the component, keep it on the hook, and reposition the entire machine instead of relying only on rotation. Within 3 machines, the solution has already changed twice. The Manitowoc moves ballast. The Demag changes the boom itself. Now the problem shifts from structure to weather. The Zoomlion ZCC 9800W shows why maximum capacity can be misleading. Its strongest superlift configuration is rated for about 800 metric tons at a 9-meter radius. Move the hook farther away, and capacity falls. For wind turbine work, Zoomlion offers a reinforced configuration capable of handling roughly 270 metric tons at a radius of 32 meters. That is the number that matters. The component is now high above the ground, much farther from the crawler, and exposed to wind. Even when the crane has enough strength, weather can shut the lift down. So the ZCC 9800W is remembered for a different reason than the machines before it. Sometimes the limiting factor is not the crane, it is the air around the load. The Liebherr LR 11000 trades headline capacity for one very obvious visual advantage: height. Its maximum lifting capacity is around 1,000 metric tons, but the hook can rise roughly 220 meters above the ground. That is about 720 feet. From the crawler tracks, the lattice boom can disappear upward until the hook is hanging above structures that already look tall from street level. This is what makes the LR 11000 useful on major wind energy projects. The machine does not need to be the strongest crane in the world. It needs to put heavy components where smaller cranes simply cannot reach. The next machine brings the weight back, more than 2,000 tons of it. The XCMG XGC 88000 is rated for 3,600 metric tons. In 2024, one of these cranes installed a propylene tower in northwest China, weighing about 2,050 tons. The tower stood 111 meters tall, more than 360 feet. It began horizontal. The lift required the vessel to be tailed, raised, rotated, and lowered into its final position, while the crane controlled more than 2,000 tons of steel through the entire movement. The main lifting sequence took about 1 hour. Within 10 days, the same crane completed lifts for 3 major towers at the project. The XGC 88000 also uses 3 independent power units, each producing 641 kilowatts. They can support one another during operation, giving the crane redundancy if one power source develops a problem. Its crawler system can move straight, sideways, or in a crab-style direction, which matters when a machine weighing several thousand tons has to reposition inside a crowded industrial site. But the clearest proof is still the tower. In roughly 1 hour, a 2,050-ton vessel, more than 360 feet tall, went from horizontal to its final position. The SANY SCC 4000A pushes the crawler category into the 4,000 metric ton class. Its main lifting structure uses a V-shaped twin-lattice boom arrangement, rising about 120 meters, or nearly 400 feet. Below it sit 4 crawler tracks driven through 8 separate drives. Behind the crane, the superlift counterweight rides on its own double crawler trolley. At this scale, even the counterweight needs tracks. The SCC 4000A was built for enormous petrochemical lifts, including process vessels that begin almost horizontal and must be brought upright as complete structures. Its maximum lifting moment reaches roughly 90,000 ton-meters, but the number that makes the machine easiest to picture is not on the hook. It can take around 150 trailer loads to move the complete crane. 150 trailers. Not for the project, for the crane itself. By the time the final load arrives, the machine has already created a logistics operation of its own. The Liebherr LR 13000 combines extreme capacity with something the previous giants have not emphasized as strongly: geometry. It is rated for 3,000 metric tons at a 12-meter radius, but the hook can rise to around 236 meters, or 774 feet. In certain configurations, its working radius can extend toward 200 meters. The crane can pair an enormous main boom with a luffing jib, allowing the operator to change the position of the hook without moving the crawler base itself. That is especially useful around nuclear plants, refineries, and other sites where the crane may have very little freedom to reposition on the ground. The LR 13000 can also work in certain lighter configurations without the full derrick ballast arrangement, reducing the amount of reconfiguration needed between different types of lifts. Its strength is not simply that it can lift 3,000 tons. It gives the operator several ways to trade height, radius, and capacity around the shape of the job. Everything so far still follows crawler crane logic. The final 2 machines do not. The Mammoet SK6000 is built around a ring. Its maximum capacity reaches 6,000 metric tons, the largest headline figure on this list. But the more impressive number is what it can handle high above the ground. Mammoet says the SK6000 can lift a 3,000-ton component at a hook height of around 220 meters. That combination was developed with future offshore wind projects in mind. Wind foundations, towers, and turbine components are becoming so large that assembling them from many smaller sections offshore can add time, cost, and weather risk. The SK6000 allows much larger modules to be assembled on land and lifted as complete units. Its working radius can reach roughly 144 meters, allowing one ring crane position to cover a huge section of a quay. The machine was also designed around containerized transport, making it easier to move between projects. And despite its 6,000-ton rating, the SK6000 can operate entirely on electric power. Mammoth has demonstrated battery operation, while grid electricity can also supply the crane where the infrastructure is available. That creates an unusual combination. One of the strongest land-based cranes ever built can be shipped in containerized modules, rebuilt around a ring, and perform its work without a diesel engine running beside it. By capacity alone, the SK6000 could finish the list. But the final crane changes something more fundamental than the number on the hook. Big Carl can lift up to 5,000 metric tons. That is less than the SK6000. But at a radius of 100 meters, roughly the length of an American football field without the end zones, the SGC-250 can still handle about 2,000 tons. That gives a better sense of what this machine can do. Big Carl works from a huge ring base that allows the lifting structure to rotate through 360 degrees. At Hinkley Point C in the United Kingdom, however, the project needed the crane to serve several major construction zones. So, dedicated rails were built between them. Big Carl can travel from one lifting position to another, fully rigged. The boom stays up, the lifting system remains assembled, and the entire crane moves as one unit. Sarens planned hundreds of lifts for Big Carl at Hinkley Point, including large prefabricated structures and reactor-related components. One documented operation involved a 382-ton steel containment ring. Once the hook, rigging, and lifting equipment were included, the suspended load reached about 575 tons. For this crane, that was nowhere near maximum capacity. Its real advantage is mobility across the project. Instead of dismantling an enormous ring crane every time the work moves, the site allows the crane itself to move. Most cranes are brought to a construction site. At Hinkley Point, part of the construction site was built around Big Carl. The SK6000 can lift more. Big Carl changes the ground beneath the project so the machine can keep moving. These cranes solve very different problems. The Manitowoc moves its own counterweight. The Demag Twin doubles the lifting structure. XCMG raises a 2,050-ton tower in about an hour. The SK6000 combines 6,000-ton capacity with electric operation. And Big Carl gets its own railway. Which one would you want to see working in person? Subscribe to Megamass for more machines built for jobs ordinary equipment cannot handle.